One of the scariest things is knowing that a missile is coming directly at you. And things can get even scarier if the missile was launched by a destroyer or a nuclear submarine. But in reality, this fear almost never exists. That's because you'll never know when one of these war machines is going to fire a missile. That's because everything is done secretly and can be done over 2,500 kilometers away. But both destroyers and nuclear submarines are only scary because of one thing: the terrifying weapons they carry. And when they run out of ammunition and need to be reloaded, it means that someone somewhere in the world is having a truly terrible day. And that also means the vessel will be out of action for at least 4 weeks while it returns to base and a real ammunition reloading operation is started. The reason it takes so long is mainly because of the vertical launch system, or vertical launch system, which are compartments that store the various types of missiles on board the vessel. From Tomahawks to supersonic missiles, these launch compartments can be over 6 meters tall and weigh several tons. They can carry up to 4 missiles loaded with fuel and explosives. And they can even hold missiles containing atomic bombs ready to wipe a country off the map. Because of this, the process of replacing these empty compartments with others containing missiles is extremely delicate and highly dangerous. Any mistake can cause serious damage or, though rare, even detonate a missile. As for the types, vertical launch system can be hot launch or cold launch. A hot launch system lets the missile use its own engine to exit the launch tube. In this case, a solid fuel rocket motor is used, which is later jettisoned, eliminating the need for a separate system to eject a missile from the launch tube. This potentially makes a hot launch system relatively lighter, smaller, and more economical to develop and produce, especially when designed around smaller missiles. However, the major potential drawback is that a faulty missile could destroy the launch tube and start a catastrophic fire on the ship's deck. This type of launch requires ventilation to expel ignition gases, since the missile's engine ignites inside the tube and could be damaged otherwise. Likewise, the launch tube itself. On the other hand, cold launch systems, despite their intimidating way of launching, are considered safer. That's because, in the event of an engine ignition failure, the ejection system already throws the missile away, thus reducing or avoiding an explosion inside the tube. This ejection system typically uses compressed air or gas. And what about the possibility of it falling back onto the ship? Modern missiles are typically launched over water to ensure any failure results in them falling into the water, not on the vessel. These launch tubes or vertical launch system are hermetically sealed and provide protection to the missile against water and possible corrosion caused by the salty seawater. A seal at the top is broken when the missile launches. And the missile launch itself, it's such a violent event that it can not only move the vessel but also damage it. That's why these launch tubes are so strong and resistant, able to withstand the tremendous force the missile generates at launch. But besides running out of missiles, a defense ship can also run out of bullets, especially deck gun bullets. Close-in weapon system stands for close-in weapon systems, which is an automatic weapon designed to destroy rockets, missiles, drones, and aircraft that have penetrated the outer defense ring and are approaching the vessel, posing some kind of threat. Located on the deck of these vessels, the close-in weapon systems consist of a 20mm M61 Vulcan rotary cannon guided by radar and mounted on a rotating base. The close-in weapon system's deck gun can fire up to 4,500 rounds per minute. Next comes a delicate reloading process, which in the initial Block 1 version could take more than 30 minutes, but now takes only 5 minutes thanks to a new automated reloading mechanism. It's not a big issue if the close-in weapon system's deck gun runs out of ammo, since it wasn't designed to deal with a massive attack of any kind, attacks known as saturation attacks. Instead, it was designed to hit missiles that penetrate through the already established defense ring. In the case of submarines, to launch missiles, they need to surface to a certain depth called launch depth and then fire. A missile, which can be an intercontinental ballistic missile like the Trident II, carrying up to 8 atomic bombs a cruise missile, or even an anti-ship missile designed to hit enemy ships. In the initial phase, they are expelled by compressed air or some type of compressed gas that pushes the missile until it is completely out of the water. Once released, its engine activates and the missile heads to the target. The other possible scenario is for the submarine to surface completely out of the water and then launch the missiles. This is the option used when the missile does not have underwater management systems. After launching missiles, the submarine can submerge again to hide itself and its launch location. And when it comes to nuclear submarines, it is known that they can sail for more than 20 years without needing to return to base due to lack of fuel. The only reasons they are required to return to base are to restock supplies on board, change the crew, and perform some routine maintenance. This incredible autonomy is due to the fact that nuclear submarines use a type of fuel with unique characteristics, in this case, uranium. Before learning how a submarine turns uranium into energy, let's first see how much energy 1 kilogram of uranium contains. Uranium is a naturally radioactive element. An element is radioactive when its nucleus is unstable. Its nucleus is unstable when it has more or fewer neutrons than it should. In this case, the atom wants to return to being stable. And it does this by releasing energy in the form of alpha or beta particles, by emitting gamma ray waves, or even by releasing neutrons. From the nucleus, this process is known as radioactive decay, which is the disintegration of the nucleus. There, in late 1938, scientists discovered that if they hit uranium atoms with neutrons, it would split into 2 other elements such as barium and krypton. They called this process nuclear fission. During this split, an energy of 200 mega electron volts was released, enough energy to move a grain of sand. It may seem like a small amount, but this comes from a uranium atom. A gram of uranium has more than 2.5 million billion atoms. Or 1 gram has the energy of 20 tons of trinitrotoluene, since 1 kilogram of uranium equals 1,000 grams. In other words, it's a huge amount of energy. And it's this colossal energy from uranium that the reactors aboard nuclear submarines use to generate power, propulsion, and drinking water for the crew on board, operating over 20 years without refueling. For example, American Ohio-class submarines usually contain between 140 and 170 kilograms of uranium and have an autonomy of 20 to 30 years. The real issue arises when they have to refuel the nuclear fuel, which is an extremely delicate and complex process that threatens the lives of all the workers involved, including the lives of citizens in nearby cities. In case of any mistake or accident during the replacement, this replacement is done in specific facilities in secret locations. Many times, the process basically consists of opening the reactor core and replacing the fuel rods with new ones, and then welding the reactor shut again. It's a very delicate process since, in case of radioactive material leakage, the workers can be exposed to radiation, and their lives can be reduced to just a few days or weeks, as I explained in another video. Afterwards, these rods are taken to reprocessing plants, or they are taken to radioactive waste disposal sites where they will remain for dozens or even hundreds of years.